All right, algebra, let's look at Unit 8, Lesson 12, and this is all about completing the square. In class, we had notes that were based on some visuals here of completing the square, saying, hey, you know, what would finish this x plus 5, and x plus 5 would be 25 little unit blocks. And then we also had ones like this that had 9 blocks, but we would expect 16 blocks to be in this corner of this 4 by 4 here. So we had to add in 7 blocks to complete the square. And the whole point of this is that if we take the 9 and the 7, that makes the 16 that we need, and we can then rewrite it as an x squared plus 8x plus 16, but more importantly, then we can use the sides of this to rewrite this as an x minus 4 squared. Nope, plus x plus 4 squared. So that is the skill that we're using today. We're trying to find the mystery value that would make it a perfect square so that we can rewrite it in factored form as a perfect square. Okay, anyway, the first part of this says select all the expressions that are perfect squares. Okay, so we could do this with pictures and all, but you know, so really with all of these, we're imagining, hey, if we take this on one side and this on the other side, will it be the same side lengths? Yes, this one is a perfect square because x plus 5 is the same as 5 plus x. It is two things that are being multiplied by themselves. That's the same as x plus 5 squared. That is the definition of a perfect square. The side lengths would be the same. This one, if we put an x minus 3 and an x minus 3 on one side and the other side, this is a perfect square. When we look at this one, x squared minus 3 squared, this is not a perfect square. If we were to build the box model for this one, we would have an x squared here, and we would have a minus 3 squared here, but then this would have to add to 0, and there's no way for this to add up to nothing because there is no other part here. So no, that one's not a perfect square. Let's see. This one is a perfect square. It's going to be x plus 5 times itself. When we multiply it, the two diagonal boxes will be a 5x and a 5x that add to 10x, and 5 times 5 would make the 25. So this one is a perfect square. And this one right here, well, 8 would split into a 4x and a 4x. And so the outside would have to be an x plus 4 and an x plus 4. 4 and 4 makes 16, but they have a 64 here, not a 16, so that one's not a perfect square. Okay, so we move on. Then this one was one where we just have to add numbers. So these first few are kind of just reviewing the skill of what is a perfect square. Well, okay, x minus 6x. Remember, the process that we do is we split this up into a negative 3x and negative 3x, and we focus on the negative 3's and we multiply them together. Negative 3 times negative 3 would give us this part here, which is a positive 9. Done. 2x splits into 1x and a 1x. Multiplying 1 times 1 together, we get 1. That's the number that we would need there. And the last one, negative 14, splits in half into a negative 7x and a negative 7x. Those are equal parts. If we focus on the negative 7 and the negative 7, multiply those together, we would get positive 49. Again, really what is happening here is we are completing this square by putting the x squared here and splitting this up into 2 minus 7x's. That is what would then allow us to work this backwards and go, oh, x times x is x squared, x times a negative 7 would make negative 7x, x times. And this is what helps us then find, oh, negative 7 times negative 7 is 49. Remember, we're trying to do this without the boxes. Okay, match each equation to an equivalent one. All right. This one's going to take some thinking here, all right? So these are all factored. And then we also got extra numbers on the other side. This is getting a little closer to completing the square. Since I have a little room down here for this one, I'm going to look at this one. Let's take that minus 6x and split into a minus 3. We would have it as an x minus 3 squared if I did that. And then the missing term that I need here would have to be a negative 3 times a negative 3, a 9. But I don't have a 9 there. So I would need to add a 9 in on this side to make this like this. And I would also need to add a 9 on this side to balance out the fact that I had to add 9 so that I could turn it into a perfect square. Turn x squared minus 6x plus 9 into a perfect square. Now, 33 plus 9 would make 42. So we are looking for this one. D matches with that one. All right, let's follow through and think through this the same way for the first one. Now, I'm limited on room, but what I do notice is that I'm gonna focus on this and write that as if it was a perfect square. That splits in half to become a -6. -6 times -6 would make 36. So I would need to add 36 on this side to complete this square on this side. I have to add 36 on this side to complete that, and that would make 42. So I would have this is equal to 42, and that x minus 6 squared is equal to 40. That matches with our A1. Okay, this one, I would take that -12, split it in half, and I would get 6. Okay, so just like that last one, I'd get an x minus 6 squared, and I would have to have 36 on this side, but I already have 6, so I only need to add 30 more to make the 36 that I would need. So I'll add 30 more to the other side. Adding 30 to both sides keeps it balanced. So this one matches with B. And the last one, in order to write this as a perfect squared, it's going to be an x minus 3, and -3 times -3 would make 9. I would have to add 9 here and add 9 here in order to complete the square on this side, turn it into that, and 6 plus 9 makes 15. So that one's going to match with the last one. C is going to match with the last one. Okay. Ooh, that's a lot. That's a lot. All right. So this part is kind of the learning target. It's really cramped on the room. So I do like the numbers that are coming up next, 4, 5, 6, 7. These are the ones that are going to be more of what we care about. Okay. Alexis solved this equation by completing the square, but some parts are missing. Okay, so what would they have to do first? Well, they'd have to take this x squared and the 12x, and they would have to, and the 13 on the other side, they'd have to add on to this x squared and 12x something else that would help it complete the square. Again, we'd have an x squared, the 12x would split into a 6x and a 6x, and so what number would go down here would be 6 times 6, which is 36. They don't have a 36 here, so we have to add that 36 onto one side so that it can be written like this, but I also have to add 36 to the other side. All right, and 36 and 13 makes 49. That checks out. They then square rooted and they square rooted both sides and square rooted this. Okay, x plus 6. So the last stage is saying x plus 6 is equal to this. Let's give a little more room for this. X plus 6 is equal to plus or minus 7. So we have two ways of like thinking about this. I can split this up into two separate problems, or I can take away 6 from this expression, and I could rewrite it as x is equal to -6 plus 7, or -6 minus 7. Because the root of 49 has two roots, positive and -7. -6 plus, now we should simplify this. These are our two answers. -6 plus 7 makes 1 is one of our answers, and -6 minus 7 makes a -13, a bigger negative. All right. Okay, this is absolutely our learning target for today. The being able to do this independently is what we're hoping for. It's okay if you're not quite there, but I do hope you're following along. Okay, with each of these, I want to reserve the space. I want to try to make my work fit in here and fit in here and fit in here. So that's why I'm going to block it off. Now, it says solve each equation by completing the squares. Because it's saying doing that, this is telling us the method. So if I want to take this and complete the square, I'm going to write it as x squared minus 2x plus a mystery number that equals 8. I'm going to build that in, and whatever I add there, I'm going to have to add on the other side. Okay, so let's think about this. Take this and split it in half. You'd have a -1, so we'd have x minus 1 squared is equal to whatever we get on the other side. Now, -1 times -1 would be +1, so we'd have to add 1 to this, and we'll add 1 to the other side. 8 plus 1 makes 9. Oh boy, the math on this is going to work out, because what is the square root of 9? It is both positive and -3. So we would have x minus 1 is equal to plus or minus 3, positive or -3. To solve this, we would then add 1 to the other side. So we're going to add 1 to this and add 1 to this. That cancels out. And our answer is +3 plus 1, which would be 4, or -3 plus 1, which would be -2. Okay? All right, solving this by completing the square. Okay, well, I know that this x squared and the 4x I need a number here that completes the square, so that if I wrote this as x, now look at this, this would be a +2 squared, okay? All right, I'm not touching the other side yet. What number would have to be here so that I could factor this entire thing out like this? Well, 2 times 2 would be 4. This would have to be a 4, but there's a -1. So it's really like I'm adding 4 to, so, no, I'm so sorry. I need this to be a 4. I need this to be a 4. So what number would I have to add on to a -1? A -1 to get a result of 4. I would have to add on 5. So here's the thing. I am going to have to add on 5 because of that -1 to make this equal the right number that I need. That means I have to add on 5 to that 7 to make 12. All right, that is what we have to do. Now we are square rooting this to get rid of the square. So we're going to square root, and we're also going to take away 2 and take away 2. So our answer for this is x is equal to -2 plus or minus the square root of 12. That's our final answer. You can take that on the calculator and solve it, or you can leave it. You can leave it like that. If I were to solve it on the calculator, I have -2 plus the root of 12, and I'll get an answer of 1.464, or I can arrow up and change that to a minus the root of 12, which is -5.464. Okay, last one. Last one. So to complete the square for this, let's think about this. This would be an x minus 9 squared for these two first parts. 9 times 9 is 81. -9 times -9 is 81, but I have 60. So what do I have to add on to 60 in order to make it equal 81? I'll have to add on 21. 20 plus 61, yep. So I have to add 21 on, and when I do, that gives me the 81 that I need, and then I can rewrite this entire thing as this. And then because I added 21 out of nowhere, I have to also add 21 onto the other side. -11 plus 21, or 21 minus 11, would be 10. And when we solve this, we're going to take the root, and we're also going to not subtract, but add 9 and add 9. So it's going to be the 9 plus or minus the root of 10. X is equal to 9 plus or minus the root of 10 is our final answer. Again, we have the option of putting that in the calculator. 9 plus the square root of 10 would be equal to, 12.16, or subtracting the root of 10, we get 5.83. Okay, again, I could write it as those two number answers, or I could just leave it like this. Both answers are here already. All right, folks, that's a lot for today. All right, hope it made sense. Take care.